Next, let's talk about soil classification. So, what is soil? Before we talk about soil classification, it's important to understand what soil is. Soil is a mixture of sand, gravel, silt, clay, water, and air. The relative amount of these ingredients is what determines its cohesiveness, or how well a soil will hold together. The weight of soil varies with type and moisture content. 1 cubic foot of soil can weigh between 100 and 125 pounds. 1 cubic meter, or about 35 cubic feet of soil, can weigh almost 3,000 pounds. Most people don't realize the force that will hit them when a cave-in occurs. If these vertical walls were to give out, for example, this worker could be buried by over 20,000 pounds of material. So let's take a look at some basic principles of soil mechanics on the next slides so you can better understand how this happens. A number of stresses and deformations can occur in an open cut or trench. For example, boiling is caused by an upward water flow into the bottom of the cut. A high water table is one of the causes of boiling. Boiling can occur even when shoring or trench boxes are used. Heaving or squeezing is caused by the downward pressure created by the weight of adjoining soil. This pressure causes a bulge in the bottom of the cut. Like boiling, heaving, and squeezing can occur even when shoring or shielding has been properly installed. An unsupported excavation can create an unbalanced stress in the soil, which in turn causes subsidence or falling soil at the surface and bulging of the vertical face of the trench. Tension cracks usually form at a horizontal distance of 1/2 to 3/4 times the depth of the trench. For example, if you have a 10-foot deep trench, you would see the tension cracks between 5 and 7.5 feet from the trench opening. Always keep an eye open for cracks developing near your trench. To determine if the crack is worsening, simply place sand over the crack and keep checking it. Sand that disappears into the crack is a good warning sign of a growing tension crack. Sliding or sloughing is another trench failure that may occur as a result of tension cracks. In addition to sliding, tension cracks can also cause the soil to topple. Toppling occurs when the trench's vertical face shears along the tension crack line and topples into the excavation. The classification of soil and rock deposits must be done by a competent person. This analysis must be made based on the results of at least one visual and one manual test. The competent person must classify each soil and rock deposits as either stable rock, type A, type B, or type C. Keep in mind that conditions such as rain, frost, or vibration could change the classification of the soil. Stable rock includes natural solid mineral material that can be excavated with vertical sides and will remain intact while exposed. Stable rock is usually identified by a rock name such as granite or sandstone. Type A soils are cohesive soils with an unconfined compressive strength of 1.5 tons per square foot or greater. The unconfined compressive strength is a system that is used to measure the shearing resistance of soils. The higher the unconfined compressive strength, the more stable it is. Examples of type A cohesive soils include clay, silty clay, sandy clay, clay loam, and in some cases, silty clay loam and sandy clay loam. The thing to remember is that even if soil has high clay content and is most plastic when moist, it cannot be classified as type A if it is fissured, it has been previously disturbed, or if it is subject to vibration from heavy traffic. These soils are fairly cohesive soils with an unconfined compressive strength greater than 0.5 tons per square foot, but less than 1.5. These soils are granular, have coarse grains, have little or no clay content, and crumbles easily when dry. Examples of type B soils include angular gravel, loam, silt loam, and so on. Type C soils are very cohesive and have an unconfined compressive strength of 0.5 tons per square foot or less. Type C soils include granular soils such as gravel, sand, loamy sand, and other types of soils which have been previously disturbed. Type C soils also include submerged soil, soil from which water is freely seeping, and submerged rock that is not stable. Soils are configured in layers. The soil must be classified based on the soil classification of the weakest soil layer. For example, if type B soil is resting on top of sandy type C soil, the entire excavation must be classified as type C. On the other hand, each layer may be classified individually if a more stable layer lies below a less stable layer. For example, where a type C soil lies on top of type A soil, you may classify each layer individually. When classifying the soil, it is important to take a representative sample from the spoil pile and from inside the trench. This will help account for soil variations on your site and ensure that your classification is accurate. Make sure you diagram where the samples were taken from on your checklist. As previously mentioned, the classification of soil and rock deposits must be made using at least one visual and one manual test. A common manual test is the use of a pocket penetrometer. These spring-operated instruments are used to determine the unconfined compressive strength soils. Once pushed into the soil, an indicator sleeve displays the reading. These instruments can have error rates in the range of plus or minus 20 to 40%. A less complex manual test is a thumb penetration test. This test involves an attempt to press a thumb firmly into the soil. If the thumb makes an indentation in the soil only with great difficulty, the soil is probably A. If the thumb penetrates no further than the length of the thumbnail, it is probably type B soil. And if the thumb penetrates the full length of the thumb, it is type C soil. The thumb test is subjective and is therefore the least accurate of the three methods discussed so far. The ribbon test can be used to test clay type material. Roll the soil into a cylindrical shape, half-inch diameter, lay the material across the palm of your hand, then press the material between your thumb and your index finger. Squeeze until it takes a shape of 1/8 to 1/4 inch thick strip and allow to hang freely from hand. Clay loam will barely ribbon and break easily. Clay will allow for a relatively long ribbon 6 to 8 inches or more. The last manual test that we will discuss is the field sedimentation test. This test can determine the sand content of the soils. With a flat bottom container at least 7 inches high, take a representative sample from the spoil pile. Fill the glass jar with 1 to 1.5 inches of soil and 5 inches of water. Then shake the jar to mix the soils and water. You will start to see larger particles settle out immediately. The silt will settle after several minutes, and the fine clays may take up to an hour to fully settle. After the soil has settled, use a soil chart to determine the soil type. For example, if 60% of the soil in the jar is sand, draw a line here. If 20% of the soil is silt, draw a line here. If the remaining soil is 20% clay, you will see that 3 lines intersect in the sandy clay loam region. This means the soil would be classified as type C. A visual test is a qualitative evaluation of conditions around the site. In a visual test, the entire excavation site is observed, including the soil adjacent to the site and also the soil being excavated. If the soil remains in clumps, it is cohesive. If it appears to be coarse-grained, sand or gravel, it is considered granular. During a visual test, the competent person should check for any signs of vibration. For cracks, that would indicate tension. For existing utilities, that indicate that the soil has been previously disturbed, and for indications of later geological structuring. The competent person should also look for signs of bulging, boiling, or sloughing, as well as signs of surface water seeping from the sides of the excavation or from the water table, of which indicate the cohesiveness of the soil. Okay, so using a visual test, what type of soil does this look like? Since much of the excavated soil remains in clumps, it is fairly cohesive. But as you can see, the soil in the spoil pile does not have some sand content, so this is definitely not type A. Now assume that the soil has not been previously disturbed, and there are no signs of vibrations, tension cracks, or layered geological structuring. This soil would most likely be classified as type B. So using a visual test, what type of soil does this look like? Since the excavated soil is very sandy and is not clumped, this is likely not type A or even B. This soil would most likely be classified as type C. Using a visual test to classify this soil, you could easily misidentify it as clay. Since the soil has been previously disturbed and there is water in the excavation, this soil would most likely be classified as type C.